Hey guys, today I want to talk to you about orbital notations, and then in a separate one I'll tell you one about electron dot notations. Okay, so in your notes we're on the part that we skipped right after electron configuration, right before we did noble gases and stuff. So it's just a small portion of that. So orbital notations, and orbital notations, my animation will work. You're going to use circles. I sometimes use lines, and I'll show you that when I do some example problems in a separate video. But you can use circles or lines to represent the atomic orbitals. And then you'll have a label underneath it to indicate the sub-level and the energy level. And I'll show you an example of what that looks like. All right. One electron, you can either have a line like this, which is what I like to do, or have a circle with one arrow. But either way, one electron, you're going to use an arrow. Generally, we start with an up arrow. Do you have to? No, but it's usually, whenever you see them, that's pretty much what it's going to look like. If there are two electrons, then remember, sorry about that, there we go, okay. If you have two electrons, remember, each atomic orbital can hold a maximum of 2 electrons. And so you would, and that's provided that those electrons have what's called opposite spin. And so when you show that on an orbital diagram, you'll have one arrow up and you'll have one arrow down. And you can either have that on a line or a circle with the 2 lines through it. So some examples. Looking at the orbital diagram for hydrogen. You would do hydrogen, you would tell the viewer that this is a 1s suborbital and there is 1 electron in the s sublevel. Lithium, you'll remember the electron configuration is 1s2, 2s1. And so you'll have a circle or a line for the 1s sublevel, have the 2 electrons in that, and then you'll have a circle or a line for the 2s, and you'll have 1 electron in that. You'll have to know about what's called the Pauli exclusion principle. This says Pauli principle, but you might want to add the word exclusion. The Pauli exclusion principle says that atomic orbitals can only hold 2 electrons at most, and they must have opposite spins. So from a highlighting perspective, for the Pauli exclusion principle, you want to underline or highlight 2 electrons, and you want to underline or highlight that they must have opposite spins. All right, so nitrogen. You'll remember the electron configuration for nitrogen is 1s2, 2s2, 2p3. So you have a circle or a line for your 1s with 2 electrons. You have a circle or a line for the 2s. Now notice for the 2p, you will have 3 circles or 3 lines because there are 3 orbitals that are part of the 2p sublevel. Now, you'll notice in the 2p, all 3 of those electrons in the 2p sublevel are up. You have now seen an application of what's called Hund's rule. Hund's rule says in a sublevel that has more than 1 orbital, and you'll remember the p's have 3 orbitals, the d's have 5 orbitals, and the f's have 7 orbitals. You will put 1 electron into each orbital before putting a second electron of opposite spin in any one orbital. The way I like to describe this is, let's say you have 2 brothers and sisters. Okay? You would rather have your own room before you pair up and have to share a room. So Hund's rule is the same idea, that you will put 1 electron into each orbital before putting the second electron into any one orbital. We can go the other way around, we can also identify elements from the electron configurations or the orbital notations. Remember, if an element is neutral, the number of electrons equals the number of protons equals the atomic number. And you've done some homework problems. You can tell me what element this is. 1s2, 2s2, 2p6. Glance at the periodic table. You should tell me that that belongs to neon. Let's say instead you were given a orbital notation. To me, the easiest thing to do with this is to convert it into an electron configuration, which would be 1s2, 2s2, 2p6, 3s1. A quick glance at the periodic table tells me that 3s1 belongs to sodium. So you should find that that is sodium. So you will have some homework sheets. You have one on orbital notation, and I will do a separate video on electron dots, and in that one I will do some example problems. But as always, if you have any questions, do not hesitate to ask. You can also reach me on Teams in the afternoons if you want to do that. So keep up the good work, guys.